Hi, the factor theorem. The remainder theorem that we covered in the previous video states that if we have f of x and it's divided by x minus a, the remainder r is f of a. So this is the remainder theorem. And the factor theorem makes use of this. Now, if we have if x minus a is a factor, then there will be no remainder when we divide f of x by x minus a. So we have the property that r is equal to 0 and f of a is also equal to 0. So this is known as the factor theorem. This condition where r is equal to 0 and f of a is equal to 0, and that's due to the fact that x minus a is a factor. This theorem is useful when factorizing polynomials of degree greater than 2. And here's an example. We have x raised to the 4th power minus 3x cubed at 4x squared minus 8. So we allow this, let's say this is f of x, let this be f of x. Now, if we look at the constant here, negative 8, we have a combination of numbers that we can actually use to find f of a, or what a would be to find f of a. So we have the factors of negative 8, we have positive 1 and negative 1, positive 2 and negative 2, positive 4 and negative 4, positive 8 and negative 8. So we'll substitute. In order to find a factor of this polynomial, we'll start with, let's say, positive 1. If that's not a factor, then we go for negative 1 and so on until we find a factor of this polynomial. So first we try f of 1. That's equal to 1 to the 4th power, which is 1, minus 3, that's 1 cubed times negative 3, and 4, okay, that's 1 squared times 4, and minus 8. And we can clearly see this is not equal to 0. So we know a being 1, and the factor would now be x minus 1 is not a factor of f of x. So we move on to try negative 1. So we find f of minus 1, and this is equal to 1. Now this becomes positive 3 and 4 and minus 8, and this is equal to 0. So we know that negative 1 is a valid value for a. So now we know, so this is not a factor, but we know now x minus a is minus 1, so that would be x minus minus 1, which is add 1. So we know x add 1 is a factor of this polynomial. So we need to remove this from the original polynomial and show it as a factor. So that's what we're going to do now. So we have x to the 4th minus 3x cubed and 4x squared minus 8 is directly equivalent to what we just found. X add 1 is our first factor. And you can do this by inspection to find what we should put in this brackets, or you could do a long division dividing by x minus x add 1. But you should get this result: x cubed minus 4x squared add 8x minus 8. You could check this by clearing the brackets, multiply everything here by x, then multiply everything here by 1, everything in here by 1, and add them all together and simplify. Now we'll call this new function, we'll call this g of x. So g of x now is x cubed minus 4x squared add 8x minus 8. Remember, our objective is to factorize this polynomial here. We found one of the factors, we need to find others. So again, we'll start with, remember these are the options we have. Sometimes there's you might have repeated values that you could use, so we use -1 again. So we go for g of -1, and this is equal to -1 minus 4 minus 8 minus 8, and this is not equal to 0, so we know -1 is not valid for creating an expression x minus a, which is a factor. So x minus 1 is not a factor. X add 1, sorry, is not a factor. So x add 1 is not a factor for this polynomial. What about if we try, now we're going to move on to 2. So g of 2, and what do we have? We have 8 minus 16 add 16, and we have a minus 8, and this is clearly equal to 0, so we know that x minus a, which is x minus 2, is a factor. So